My name is Sarah Blackmer, for those of you who don't know me, and I am the Defense Sector Development Director at the Michigan Defense Center, which is a business unit of the MEDC, and we're really excited to be a sponsor of today's event as well. It's my pleasure to moderate this morning's panel on the future of robotics in Michigan, but before I get started with that, I really want to take a minute to thank Rick Jarman and Rebecca Taylor, Phil Callahan, and then the rest of the staff at NCMS for hosting us this morning. I'd like to thank Congressman Dingell for his words. I know he couldn't be here with us, but it was really great of him to do that video for us to be able to hear him. And also Dr. Jim Overholt, who I think is being interviewed right now by the press, but really appreciate his words and definitely getting us excited about innovation. So Jim, thanks for doing that as well. But specifically, I'd like to take just a really quick minute to thank Andy Dallas from SOAR Technology for his energy, his enthusiasm, and his passion. For without him, there would be no today in Michigan for this event. So thanks very much, Andy, and thanks to all of you for being here today. So I'm really excited about this panel. This panel is going to speak to us today about robotics in Michigan. What is it that Michigan has to play in robotics, specifically across multiple industries, which is very exciting. So not just necessarily that we are a manufacturing state or that we are an automotive state, but across multiple spectrums of different industries and how those possibly cross-connect. And so I think it's going to be a really great panel. Let me give you a little bit of the mechanics. So our plan this morning is that I'll make introductions of all of our panelists, and then I'll give them a chance to talk a little bit about robotics in their industries and then their idea about the future of robotics in their industries. And then we'll open it up for Q&A. But when I talk about Q&A, we are a very intimate group here. So let's remember that you have as much to offer as we do. So let's keep it more of a discussion based. And if you have a comment that we can comment and comment, then let's have a discussion of 100, and that will be really great too. It doesn't necessarily just have to be a question that gets answered. So let's try and do that. So first, I'd like to introduce the distinguished members of our panel, and I'll start right here in the middle with Corey Clothier. So representing the entrepreneurial and maker community is Corey Clothier, and Corey is the co-founder of 6Zulu, a strategic planning consulting firm specializing in national collaborative research and development initiatives. And he, along with Mark Salamango, who you will get to meet later this afternoon, co-founded this really cool thing called Robot Town, which is a living laboratory for robotics applications. Corey earned his BS from Northrop University, his MBA from Baker College, and he is currently pursuing a doctorate degree in business strategy at Cranfield University with a focus of study, which is very cool and appropriate for today, looking at the DoD as being a business incubator for automotive robotics entrepreneurs. So we're really happy to have Corey with us today. Corey also served at our country as a captain in the United States Marine Corps, so be sure to thank him for his service later today as well. Representing the medical community right here to my right is Dr. David Felton. Dr. Felton is the Vice President of Research and the Medical Director of the Research Institute for Beaumont Hospitals in Royal Oak, Michigan, where he oversees the hospital's research portfolio. David received his BS from the Massachusetts Institute of Technology, an MD from the University of Pennsylvania School of Medicine, and a PhD from the Institute of Neurological Sciences, also from the University of Pennsylvania. David is very well decorated, and among his many accolades is the John D. and Catherine T. MacArthur Prize Fellowship, and I know you loved that, thanks. And then I'll go all the way down to the very end. Representing the defense community is Jeff Czachowski. Jeff serves as the Deputy Project Manager for the Robotic Systems Joint Project Office under the Program Executive Office for Ground Combat Systems at the Detroit Arsenal in Warren, Michigan. He is responsible for developing, acquiring, and fielding ground robotics for the Army and the United States Marine Corps. He earned his BS in Electrical Engineering from GMI Engineering and Management Institute and his Master of Science degree in Engineering Management from Oakland University. Jeff was also recently recognized by the National Defense Industrial Association for his leadership and work in the field of robotics. So Jeff, thanks for joining us today. Representing the transportation community is Jeff Rupp, right next to Jeff Czachowski. Don't get the Jeffs confused, but they're next to each other. Jeff is the manager for Safety Systems Engineering at Ford Motor Company and has over 20 years of experience with Ford. For 9 of the past 10 years, he led Ford's active safety research, developing 3 generations of accident avoidance technologies that are on the road today. He earned his bachelor's degree in mechanical engineering from the University of Michigan, his master's degree in systems engineering and engineering management from Wayne State University, and Jeff has been awarded 8 safety-related patents and has participated in every single DARPA Grand and Urban Challenge. And then finally on our panel, representing the industrial robots community, is Bob Rochelle. Bob is the North American Sales Manager at Kawasaki Robotics with responsibility for robot and automation system sales. He also serves on the Robotics Industry Association Board of Directors. Bob has been in the automation industry for over 25 years and earned his bachelor's and master's degree in engineering from Virginia Tech, but don't hold that against him. No, I'm just kidding. He has taught at both the university and community college levels, is a frequent author for technical journals, and holds numerous U.S. and international patents in the automation and food packaging fields. So you can see we have a very distinguished group of gentlemen in the robotics community here to talk to us today. So thanks very much, guys, for being here with us this morning. So I want to take just a minute and let each one of them introduce their company and or their organization and what that play is in robotics with respect to those fields that we discussed earlier. And so I'll go ahead. Phil, do you have an order, or should I just start at one end? I know you have them in. They've got slides. Or that's okay.
I heard a good joke. I heard a joke from Sarah's son last year at First Robotics Finals. It's pretty good. This guy is driving down the highway, and he happens to have penguins in his car. And police notice it, and they pull him over. And he says, "What are you doing? Why do you have penguins in your car?" And he goes, you can't drive down the highway with penguins in the car. You need to take these to the zoo." He's like, "Okay, officer." So the next day, he's driving down the same highway. Same police notices he still has penguins in the car. Pulls him over. He says, "What are you doing? I told you to take the penguins to the zoo." He goes, "I did. Today I'm taking them to the beach."
So I took my 9-year-old and my 6-year-old to the first state finals robotics competition with Jim Overhold and Corey Clothier and Mark Salamango last week on Friday at Eastern Michigan University. And one of the displays, you could get swag, but only if you entertained those teenagers. And so one of the things that my 9-year-old did to entertain was tell a very clever little joke. So now you guys get to be entertained as well.
That's good.
So Jeff Jakowski, please start us off and talk to us about robotics in defense.
Okay. The pictures didn't come out there. You see? Okay.
Ooh.
All right.
They were awesome.
I want to I'm going to pull a couple threads that Jim Overhold talked about earlier. And so as I introduce RSJPO, the Robotic Systems Joint Project Office, 3 things, then I'm going to come back to requirements, enablers, and how those tie to where we're going with military robotics in the future. And then the third thing that Jim talked about was, if we're not fielding, we're failing. So first thing, fielding. When we talk RSJPO, Robotic Systems Joint Project Office, what's our mission? We are the chartered acquisition agent for Army and Marine Corps for ground robotics. Now what does that mean, chartered acquisition agent? By the acquisition agent, we're responsible for the full life cycle management of ground robotics for both services, the Army and Marine Corps. And within that life cycle management spectrum, we do everything from the acquisition and procurement, the fielding, the sustainment and training, and then the disposal of those systems. So we're looking across the entire life cycle of a military weapon system, that system being a ground robotic system. And we're fielding these systems to the warfighters. You see here, we've got right now 2,700 robots that are either in Iraq or Afghanistan. We have about another 1,000 that are stateside that are used for training assets among a multitude of what we call home station sites, like Fort Bragg, North Carolina, Fort Campbell, Kentucky, Fort Lewis, Washington, Fort Hood, Texas, Fort Carson, Colorado. We have robots poised at all of these locations to assist with military pre-deployment training. Our soldiers and Marines are familiar with the operation and the tactics techniques and procedures of how to operate and employ these systems once they get to theater, and where they'll fall in on these systems. So in the where we're located, we are a global program management office, about 230 associates that covers our core PM folks, military, matrix from some partner organizations, and then we have a handful of contractors that support our organization. We're based at the Detroit Arsenal in Warren. We have a contingency at Selfridge Air National Guard Base that we call our Joint Robotic Repair and Fielding activity. It's the hub of how we do our support and sustainment of theater. So our technicians, what we do is train our technicians that go to theater to do the repair, theater training, and sustainment of robots. We do that out of Selfridge. And then we also, that's our primary warehouse function, so we call it our inventory control point, where we have a stock of spare parts that we push on demand to our theater sites. So where are we in theater? We have 5 robotic repair detachments in Afghanistan. We're down to 1 in Iraq. We used to have 3. As we're drawn down in Iraq, we've pulled all of our assets to Camp Victory in Baghdad. So we've got a hub remaining in Iraq. We'll carry that mission through till about the end of this calendar year, and then we'll draw out of Iraq with the remainder of the support echelons there. The numbers here have changed over time, over the past year and a half. So basically they flip-flop. We used to have over 2,000 robots in Iraq, and now you see that number is just basically flip-flop. So as we've drawn down Iraq, we've pushed a lot of those assets over to Afghanistan. The other pictures that would have shown here would have gave you a little more idea of our portfolio, the systems that we have. They are primarily small robots that are teleoperated. So there's an operator control unit or a robotic interface that the warfighter uses to get feedback from the system to do his mission. And the missions in the early phases of the war, I'm talking early 04 through 06, going into 07, it was primarily for counter IED, counter improvised explosive device, and explosive ordnance disposal. Going into 08 and then into 09, and now in the last 2 years, robots have begun to proliferate beyond just being the niche application for counter IED and EOD to other military missions, to include maneuver force, which is reconnaissance and surveillance, and for military police for entry control points and perimeter security. In the past year, over 1/3 of the robots that we fielded have been to non-EOD or non-EOD or combat engineer forces. So it shows that on the user side, as robots are becoming more capable, our warfighters are seeing the applications expand beyond just counter IED and EOD. Now into future trends that are being developed in requirements by our users. So that's another thing that Jim talked about, was requirements. And I won't belabor any of the enabling technologies that Jim talked about, but the enabling technologies provide our user community the background to build attainable requirements. So we're not coming up with requirement documents that are unachievable in a finite time frame. So by working with the tech-based community, we can level set what those requirements look like. And in priority-wise, capability needs that the user has defined are now being codified in requirements that will drive future programs. Number one, it remains counter IED. It is the our adversary's weapon of choice, and our user sees robotic systems as a primary deterrent or counter to that threat. Number two is lighten the load. If you look at what our soldiers are carrying, our warfighters are carrying, Our infantry are sometimes carrying over 100 pounds each. So how much can we offload the weight that's on the back of a dismounted soldier, talking in the elevations of Afghanistan and the terrain, and put it onto a system that can go where a dismount goes, so there comes to some mobility challenges, and carry some of the gear that the warfighter normally would. The third area is reconnaissance surveillance. We call it persistent stare. The ability to put eyes on a hot spot, maybe an IED hot spot, or some other area of interest. Be able to put a robot out there and conduct that mission, provide increased situational awareness and tactical advantage to our warfighters, build that common operational picture. The fourth goes to convoy and cargo logistics. Being able to outfit our current fleet with we call it robotic applique, but that middle ground that Jim showed, taking robotic technology onto our manned systems, so we have a manned, unmanned, an optionally or a remote optional capability to do things like move cargo, automated convoys, have a unmanned vehicle out front of a route clearance team that could encounter the first blast. And then the fifth area is chemical, biological, radiological, nuclear, we call it CBRN, being able to put payloads on robotic systems to go into those type of environments that are hazardous to a human, and Fukushima is a perfect example. We have robots there right now that are going into the site to take readings, look for structural integrity, and here would be a perfect example. In the early stage, I think we missed the sweet spot, but some of the fire trucks, the firefighting vehicles that were sidelined because the humans couldn't take them close enough to the reactor to spray them. So if we had a applique kit to put on those firefighting vehicles, take them downrange next to the reactors and do their job, at a safe distance. So that's kind of where we're headed in a capability needs, or where the user's pulling us. I don't know, do you want to talk now about how Michigan can play, or is that going to...
Let's wait.
All right.
Let's wait.
Okay,
Thanks very much, Jeff. I appreciate that. Jeff Rupp, then, from Ford. Can you talk to us a little bit about Ford Motor Company, and then also about what their play in robotics is right now?
Sure. Yeah. So I think I've got a slide. Yeah. Right. So when you think of an automaker, you probably think of building cars with robots in an assembly plant. But when I think about an automaker, I like to think more like Jules Verne, and think of building cars that are robots. And so if you can go ahead and build this next thing. Okay. So if you look at the safety model, and this is how I'm going to kind of explain how I got to where I'm at today. So when you look at our safety model, we think about the crash that happens. We think about all the events that lead up to the crash, all the way from just normal driving, you're just doing your thing, you're totally safe, to, not yet, no, I'll tell you when. You can go back and say, yeah, not yet. So, all the way to after the collision, and what happens there? Okay, so now, right. If you go ahead and build, yeah, okay. So when you decompose that safety model, you see that there's a lot going on. Okay, so you've got normal driving, you've got high-risk driving. Maybe you're juggling 2 cell phones and you're texting or whatever. And then the driver makes a mistake, all right? And 90% of the accidents are caused by driver error, approximately. Now, just because you've made a mistake doesn't mean you're going to have a crash, but you're in this incredible hazard zone. And if things progress poorly, you get to a point where the crash is unavoidable, all right? But there's still an opportunity to do something in that time frame to maybe lessen the severity of the crash. And if things progress, they result in an impact. You hit something, but you haven't stopped yet. You're still in contact with this other thing, whatever it is, and then you separate, but you're still moving. You might hit another car, you might hit a tree, you might go into a ditch and roll over. And then eventually you come to a stop, and there you are in your car, and there's you in the car in the world, and maybe there's an opportunity to do something there as well. So go ahead and next slide. Oh, there we go. So this one didn't come through quite as well as I'd hoped, but there's really two sets of information here. The boxes really talk about actions that we can take to help the driver in each of these phases. Okay, If the driver's distracted, we can maybe bring him back to attention. We can monitor what he's doing and infer what he might be thinking and help him out. We can inform the driver in terms of judgments. Is this road slippery or not? Is there ice up ahead or not? When you get into the imminent collision mode where the collision's unavoidable, maybe we can help them apply the brakes to lessen the severity of the crash, and so on. And one more, Bill. Okay. This isn't quite readable yet either, but let me just kind of highlight that some of these features that we've built are actually autonomous. Okay, so we have adaptive cruise control, as Jim Overholt mentioned this morning, controls the throttle of the car. We have self-parking systems that control the steering. And we have collision mitigation by braking systems that control the brakes. So we basically have all the pieces that we need to build and field an autonomous vehicle. So that's our robot, and that's our I'll say our other perspective on robotics at Ford.
Okay, great. Thank you very much. And then we'll go to Corey, maybe you can talk just a little bit about 6 Zulu or about Robot Town specifically.
Sure. See how that looks on the screen. Okay, so here's a really cool, I actually even say sexy picture from Mark Salamango. His creative vision of Robot Town story is what we're doing. So this, without trying to sound, I don't want to sound redundant, but my day job with 6 Zulu, I've been working with Jim Overholt for about 3 years, so I'm working with Jim on national strategies, and he kind of phrased me as his business guy. And so we work on, which sounds kind of odd, a business development person within the Army community, within the government, but that's essentially what I do, is I help them find opportunities and help validate different investments and do a lot of research, write papers, and lately starting to put these ideas to paper in proposal form, those types of things. So that's my day job. And then Robot Town is becoming my evening and weekend job. And I'm going to enlist most of your help on it probably today. So it's a lot of work and no money, just to let you know. So Robot Town, living laboratory, you've heard that stated a few times. So the concept of Robot Town is a living laboratory, but in a consumer commercial setting. So we're looking at Southeast Michigan. We've got multiple locations that we're starting to look at. We've been talking with the state, a lot with Sarah and MEDC, Defense Center. A couple places in downtown Detroit seem interesting. Ann Arbor is definitely interesting. But this becomes a collaborative hub and a maker community. But first and foremost, it's a test center. Is that we need hours and hours and hours on robots. Our focus is ground mobile robotics because we're Michigan and we make automobiles and we make things that are on tires and tracks. So we should own that space. And talking with a lot of our robotics leaders around the country, they agree, and they're going to support us in that as well. So it's kind of just a real high-level view of Robot Town. Is it's going to be for education. There's going to be elements of security, service, those types of things. I definitely want to talk to Beaumont Hospital about if we could put in some service robots in the hospital setting, because I know that's an application that's going on. And if we can put thousands of hours on there, we're going to start increasing reliability. So our intent behind this is really that transition point. There's also an element of it provides a showcase for anybody who's in this space commercially. If you're a small company or a large company building robotics, this test center will be a test center for you to actually do some rigorous testing on your robot, but it could be a showcase. You could show it off to potential clients and customers. So we're doing this with the intent of having the federal government behind. We're going to take it all the way up the chain and see if we can get the president behind it one of these days once we gets fully formed. Right now we're in the strategy and vision. By the end of the summer, we plan on having a pretty well-formed strategy, and I say pretty well-formed in Marine Corps terms. We're kind of 70 and go, and I'm even a little aggressive, maybe 60%, and I'm ready to rock and roll. So we're moving pretty aggressively on this thing, and so that's our story of Robot Town, and we'll need your help.
Okay, thank you. Bob gets to talk to us today about two things. So Bob represents Kawasaki Robotics for industrial robot applications, but also he is on the Robotics Industrial Association Board of Directors. So we get to hear both about Kawasaki and then also a little bit about the RIA.
Okay.
So Bob?
Thanks. Good morning, everybody. Let me start with the RIA. The RIA is the Association for Industrial Robots. It's about 250, 300 companies. We do work, well, we're most known, if you read the slide, we're most known for the safety standards by which we all install our robots in industrial space. We also do educational outreach. We do some market study. And it's a group that all of us belong to and all of us support in the industrial space. And I would like to take a moment to introduce the Executive Vice President of the RIA. He's here today, Jeff. You knew I'd pick on you. He made the long trip up the sidewalk from the office to come in and visit us today, right? So that's the RIA, and I was asked by the RIA to be here today on behalf of Kawasaki Robotics, but we need to involve the RIA as well. So if you'll carry on to the next slide, please. Okay, I'm with Kawasaki Robotics. Briefly about the company, we're a division of Kawasaki Heavy Industries, headquartered in Kobe, Japan, way south from the earthquake, but we did have concerns there. We are located in Wixom, Michigan, and you see some branch offices around the country, and I also put our international branch offices up. The photograph in the upper right is a Kawasaki motorcycle, because everybody knows us for motorcycles, but very few people know us for robots at the moment. We do system sales for the industrial space. We build a variety of systems inside our building. The industry, which I'll talk about in a minute, we kind of specialize in different industrial spaces when you're in our world. Kawasaki does paint, heavy deposit welding, and material handling. That's what we do, as defined. We do a 300 to 700 kilogram 6-axis arm. We do some palletizers, and we have what we call a flex picker of the Delta class. So very briefly on the company. We do use integrator partners located globally. When I talk about the industry here in a minute, you'll understand integrators versus us. And I put 2010 robot sales up, and it's been a whole lot better than 2008, 2009. So just so you know, that's a little bit about Kawasaki. We are not the largest robot manufacturer in the world, but we're one of them. So speaking then about the industrial robotics industry itself, you see some numbers there. There's over 850,000 at work today. Revenues $5 billion and $15 billion in systems. Now I've got to be very honest with everybody. It's probably 2007 numbers, because 2008 and 2009 I didn't really want to put up here on the chart. Matter of fact, I recently had a sales meeting and we did the sales chart from 2000 through 2010, and I eliminated 2009. And only one of my integrators picked up on it, so that was kind of cool. I didn't want to go and then back up again, so I just took it off the chart, and one guy had to pick up on it in the group and ask, of course. So anyhow, we have as an industry had a growth rate as high as 18% yearly. This is over years and years and years, and the good news is first quarter 2011, the numbers just came out, and we're up a good 30% plus. And the other good news, in deference to my automotive colleague to my right, outside of automotive has grown much more than non-automotive sales, which speaks to what's going on in this room today. And again, our industry, the largest users are still automotive and electronic. And if you look at industry growth over the past, let's say, 20, 25 years, and when automotive is up, electronic was down, electronic is up, automotive used to seesaw. In the last 2 years, they were both down, as we all know. So nonetheless, automotive is still our big brother, and it is the largest portion of our industry. And I list the major applications there, but one other thing to note as part of this celebration today, 2011 is the 50th year anniversary of the first robot installation in an industrial space. The first one was installed in 1961 in a GM plant in Lordstown, Ohio. So we celebrated that at our last trade show. So thank you.
Thank you, Bob.
All right.
And so last, but of course not least, Dr. Felton is going to talk to us about Beaumont Hospitals in Royal Oak, but then also about how robotics is part of his research portfolio.
Yes, I oversee a sizable portfolio of research at Beaumont Hospital. We have close to 1,000 clinical trials in almost 100,000 patients actively, and we're just approaching 300,000 patients in our entire clinical trials database. We also have a huge core molecular laboratory and a biobank that puts all of the modern equipment, and I do mean the latest in wonderful genomic, proteomic, and other technologies, all in one contiguous place, completely interdisciplinary, completely non-siloed. So we are in the process right now of really working vigorously on molecular biomarker discovery. But we do have, also I was going to mention, we have a School of Medicine that we have started with Oakland University, and we're really moving forward into a new era of becoming even more of an academic hospital than we were. Currently, when we think of robotics in medicine, Beaumont has many, many surgical robots, the Da Vinci robot. We use it for prostate surgery, OBGYN, colorectal surgery, otolaryngology, and we also have a Da Vinci robot in our simulation lab so that people can practice and try out new ideas. The advantages are wonderful dexterity, haptics beyond human skills, sensing ability, the ability to navigate with imaging, and of course the goal is safety. If you mess up on safety, you're down the drain. Safety is everything. Safety is now the metric, and any hospital that messes up on safety is going to find itself poorly reimbursed and in serious trouble. The disadvantage is, if any of you have seen the Da Vinci robot, it's a great big clunky machine. It has a huge learning curve, like you need to practice 100 times before you become adept. And it's not surgeonless. We would like to get to the point of having surgeonless surgery. I don't know what our surgeons will do if that happens, but they still will be doing the history, and I keep coming back to that. History and physical is the heart and soul of medicine, even in the face of all the imaging technology and all of the diagnostics we have. Future directions are to make the robots smaller, more flexible, more task-oriented, more remote, and perhaps ultimately autonomous. A longer-range future is surgeonless surgery, where we can take patient data, real-time imaging, and an ability to respond to unexpected challenges, which is the daily life of a surgeon. Next, please. We also have image-guided neurosurgery and radiation oncology. This is an amazing technology. If you're irradiating a tumor that needs to be, have radiation therapy, if you just send the beam in from one direction, you absolutely fry normal tissue. And it greatly limits the amount of radiation you can deliver. If you could send the beam in from multiple directions, you can reduce the amount of damage to any one area of normal tissue. So we do that with image-guided and computerized machinery that allows us to accomplish that. And then we have the patient lying on a table that has been designed by our radiation oncologists under Dr. Alvaro Martinez, so that the table moves and has real-time stabilization of the tumor. So as the patient is breathing in and out, the table moves the patient so that the beams continue to crisscross into the tumor and fry the tumor. It's a marvelous technology, and it depends on real-time imaging. And in fact, Dr. Martinez got the idea watching a Ford Motor Company presentation of how they were imaging moving parts of a motor, and thought, hey, I can do this. I can do this with humans. So the challenges are to somehow get smaller, more advanced robotics, and get some of our colleagues from other industries, from the military, from industry, to work with us, because we don't need to reinvent the wheel in this. And by the way, one other area of application is we have a huge reference lab, the third largest reference lab in the world, in the United States, at Beaumont, for measuring blood levels. And that is entirely robotic. In fact, it's completely automated, and those robots will actually send notification to the plant to send out a repair technician because there's a circuit that's going bad. It's a marvelous new technology, right until nanotechnology replaces it with real-time measurement using fluorophore technology, so that you can get real-time measurement of those same levels without having to send it to the test lab. Next, please. Now, I think a future of robotics is going to be in microbots and nanobots. I think we can have nanoengineering to assemble and then move and then reassemble tiny little nanobots for repair of DNA, or for recognition of DNA that's aberrant. If you can measure it, you can do something about it. If you can detect it, sense it, you can do something about it. We can sense DNA very well because of the base pairs. In fact, that's what in situ hybridization is all about, which, by the way, is also totally automated with a robotic platform now. Once you can do that, you can hook the DNA molecule to go out and seek out that DNA. You can hook it to a little microsphere or a nanosphere and send it out on a journey to go find that. So you might be able to repair DNA. Detection of cancer cells is coming down the road. It's very real. We are dedicating a huge effort at Beaumont to finding biomarkers of specific tumor types. And if you can, for example, some of the cell cycle proteins are expressed on the surface of cancer cells, and they're aberrant. They have a slightly different three-dimensional conformation. Well, you can go find those. We evolved as humans with an immune system that is masterful at identifying subtle changes in proteins and peptides. If that's the case, if the immune system can detect it, we can make a machine that can have that antibody hooked onto it to go seek out that particular aberrant molecule, grab onto it, and then do something secondary, like release a lethal substance very close to the tumor cell to destroy it. And then we can also detect vascular plaques and go in and try to maneuver around some of these unstable plaques, which if they rupture will give you a stroke or a heart attack, identify the lipids, and then either eat the lipids or identify the lipid and release some types of trophic factors or chemoattractants to get cells to come in and repair and rebuild the endothelium in the wall, which right now even stents won't repair because of the Swiss cheese-like effect of drug-eluting stents. We know how to detect all of the above. We've got the technology. We also have the microspheres in the laboratory that can identify 20, 30, 40 proteins at a time or peptides at a time. We need help from industry, and we need help from the engineers and the robotics specialists and the microbiologists to come in, molecular biologists to come in and help us engineer this with a team. And I think we can also end up going after neuronal plaques in the brain and neurofibrillary tangles by getting a plaque that can have a lipid hooked onto it to allow it to cross the blood-brain barrier and either grab onto some of the inflammatory mediators and get rid of them, or mess up some of the microglia so that they're incapable of engulfing and destroying some of the neurons. Next. We need sophisticated sensor technology for ablation of pathologic tissues, and we need to incorporate some artificial intelligence into this so that the little microbots and nanobots can actually learn by looking and sensing something and then triggering a learning program so that it knows what to do next. And I also think in the farther future, we need to be able to look at signal transduction pathways in cells. As you may know, there are dozens of signal transduction pathways that detect outside molecular input, translate them into a cascade of molecular events that ends up with nuclear transcription factors that allow a cell to express genes differentially so that a particular cell can express genes for a heart cell or genes for a brain cell or sometimes, unfortunately, genes for a cancer cell. And if we can have detection of some of these signal transduction pathways and do the complex nonlinear mathematical integration of these interacting pathways, I think we will be able to much better be able to assess what needs to be done for treatment programs. And then let's go to the next. Oh, can I go back for a second? It was something in a conversation that triggered this. We need to have an R2-D2 who can help us in our hospital. We need to be able to have an R2-D2 who can help us with transportation and help us untangle the mess of handoffs and transporting. You know, we've got thousands of patients. We see 2 million outpatients a year. We have the biggest volume of surgery in the country, virtually tied with the Cleveland Clinic. The logistics of handling all those patients is just nightmarish to try to coordinate. We need robotics to help us do that, and we also need to be able to remotely watch patients so that if there's an aberrant breathing pattern or if a patient is getting up and looking like they're in a position where they could fall, you need to be able to sense that remotely and send a message to the nursing station to send somebody in to take care of it, so you don't have to have somebody sitting at the bedside 24/7 watching a particular at-risk patient. And then last, what do we need to do? We've got some real needs for the future. We need working teams that will integrate from many, many different disciplines. We have to find the proper incentives and move away from the autonomous academic researcher with independent R01s, grants, independent publications, standalone, I am the expert in my field. You know what happens in a university if you're a collaborative investigator. The same thing that happens if you win a teaching award. Get your CV ready because you're going to be sent packing. You won't get tenure and promotion. We need partnerships with biotech companies and industry and hospital and government labs to get the synergies, to get this disparate group of people working together. For example, we just work with Oakland University to integrate clinical information from Epic, our new electronic medical record system, information from our electronic data capture system, Crossbreak, which is a home-invented platform, Big R, which is our biobank platform, and also the data coming from 31 pieces of equipment, to integrate that seamlessly into a single searchable database. And it took the computer scientists and some of our engineers working with us and our experts in the biobank and our experts in clinical informatics working together to get an integrated platform that I don't think anyone else has. We also need to solve some of the disincentives that can happen when you start wrangling over IP ownership and business capital needs. And of course, big business wants to be able to make $11 zillion off of an invention, or they're not interested in developing it if it's big pharma. And sometimes you need to move slowly and get a pilot project going and show proof of concept, and then move into the really big industrial areas. We would like to see small business, large business, universities working together to try to put the right proposals together so that we can have financial incentives to really have truly interdisciplinary teams. That's what we need. We don't need to reinvent the wheel, but I think there is a fabulous future ahead for big robots, micro and nano robots, and an opportunity to truly make the environment in a hospital safer and more predictable, and also to achieve some of these preventive and protective programs that the President and I think most of the Congress really fully supports, of being able to prevent strokes and heart attacks and type 2 diabetes and all of these terrible chronic diseases that we face, to be able to go in with the little micro and nanobots and clear up the problem before it becomes a disaster. Thank you.
Great, thanks, David. So we heard a lot from David and then also from Jeff Jakowski about maybe the future of where robotics are going, both in the medical community and then defense community. But I'd like to hear a little bit more from Bob, Corey, and Jeff R. Can you tell us just a little bit more for industrial robots? I mean, is it electronics and automotive? Is that really it? Corey, for entrepreneurism and the maker community, I mean, where is really the future play for robotics for that? And then, Jeff, is it really just, the car equals a robot? I mean, is that what transportation is going to look like for robotics? So if the three of you can just really quickly go through kind of what you see as the future in those spaces. And Bob, why don't we go ahead and start with you?
Okay. Well, the future in our industry, of course, all the major industrial robotics companies, except one's located in Southeast Michigan, and oddly enough, that's because we all live and breathe in the automotive industry. So our future is going to be outside of that industry. I don't think we'll see the same numbers of orders that we've seen over the past 20, 30 years in automotive. Automotive will continue to be the big brother, but we all have to be outside. And when I say outside, it's the medical, the food, the life sciences, just other industries, other areas. There's prediction that the food industry could possibly supersede the automotive industry in the number of industrial robots in the next 20, 25 years. So we all need to work in that industry space.
Okay, great. Corey?
So our focus is on ground mobile robotics and automotive robotics. So that's kind of where our head is right now, because there's so much to do in that space. So one of the things in Robot Town that we're working on is, obviously Jim mentioned, increasing reliability in robotics to automotive standards. So we can't do that any better than here in Southeast Michigan.
Right.
But one of the interesting things, we keep name dropping some of the same people, but Dan Bart's kind of educated us on the unmanned aerial vehicles, or the UAVs, how they really came to be through the do-it-yourself community, the people in garages and at universities. And so this kind of hackerspace, makerspace really looks like the future. And Jim had a vision of, he really felt that the do-it-yourself community could have a really significant impact on ground mobile robotics like it did on the UAV community. So we really, really believe that. And I was just looking last night, I was just kind of scanning through. There's a gentleman, anybody know who Andrew Archer is here locally? Andrew is becoming a famous young roboticist. He has a robot pilot going on at GM right now for a logistics platform, and it's a line follower with a vision system, so it has obstacle avoidance with the line follower. He's 22 years old, doesn't have a formal degree, and pretty much considered a genius. He won national level robotics competitions at age 16, 17. And he's a local guy that's in this hacker makerspace, and he's been recruiting people like crazy. And so as I was just reading his story, there's the A2 Mech Shop, and almost all of these are in Ann Arbor, strangely enough, right? The GoTech Makers, All Hands Makerspace, O2 Creative in Royal Oak, I3 Detroit in Ferndale, Work and Tile Exchange, also in Ann Arbor, and then a new one, OmniCore Detroit. All of these are considered hacker makerspace that are fairly new, just within the last couple of years. So it's really starting to take off, and we think that's where the future, a lot of the future is going to come from there.
Great. Thank you. Jeff, for transportation?
Yeah, thanks. Phil, there's one more slide. Could I show that? Or are you already powered down?
No. Okay.
So I like using pictures and graphs. I didn't get to put together 30 slides, so I put it all into one slide. Yeah, so I don't know. This picture for me is, it's robotics is kind of addictive. Once you get in and you start playing this game, you have a lot of fun doing it. And we've kind of come up with this motto of do cool stuff until you die. And this is, I always have to look at it, sorry. And
So say it again so that everybody can hear it. One more time, the motto.
Do cool stuff until you die.
That's your takeaway for today, folks,
Yeah.
right there.
And so this is a picture of our robot at the DARPA Urban Challenge held a couple years ago. And this is kind of the punchline of where we'd ultimately like to go, is a car that has the ability, not necessarily it will drive without you, but has the ability to drive without you. But you'll be there. And it needs to be an interactive experience. In this particular challenge, when you're in the heat of battle, you want to win. We didn't win. Another automaker won. But we learned a ton. And I think really the vision for me, the nearer term attainable vision is what I can do in the meantime. We've already learned quite a bit that we've put into production, and I think we're right on the forefront in terms of features that are in production that are saving people's lives today. So can we go to the next build? Okay. So in terms of passive safety technologies, we've got a ton of things to do, a ton of things that we've already done before we get to this ultimate self-driving car. The most recent thing, inflatable belts. Okay, so if you can't keep the crash from happening, we're going to minimize the consequences of having a crash. So the two really still have to go together until you have this perfect robot that will not crash. Another click. So when you add environmental sensing, situational awareness enablers to the vehicle, you have this whole other set of support that you can provide to the driver. And as you can see, in terms of a safety opportunity, we're starting to get into the sweet spot, and we've delivered a lot of these technologies, but there are still more use cases yet to come. So one more click. So now you see kind of out at the end of the active safety curve, you see full autonomous drive, but there are still a bunch of other features that we want to deliver between then and now. The research needs to continue on these fully autonomous vehicles, getting into Robot Town, and all these different things where we're going to collect data in real-world environments. But we want to deliver things to customers that they need now, that we can deliver now. The cool thing about it is I've been focusing on safety, and really that's my passion. But when you start to deliver these other features, you're also enabling other things. Okay, so drive smart. We have comfort and convenience features that make the driving easier. And you also have drive green enablers, which are for improved fuel economy and lower emissions. So there's a lot of other benefits that will come, but we really think at Ford that safety is the prime driver and the motivator, and that's going to guide us for the near and long term.
Okay, great, thank you. And we can probably pop up the license too. Okay, so we have about 20 minutes left, and I'm gonna get us gearing here towards why Michigan. And then I'll ask this one question, and then I'll open up the floor if anybody's got a question. Otherwise, I could go on forever. But so let's talk about why Michigan. Jeff Chakowski. So the DoD puts their whole ground community center of excellence in Michigan. You know, what is that about? Corey, you will have this opportunity to do this really cool living laboratory, and you say, you know what, I'm thinking someplace in Detroit, or I'm thinking someplace in Ann Arbor. Bob, Kawasaki, I mean, this is not an American company, right? But they want to be here in Michigan. What is that about? What is the draw to Michigan? Why is Michigan the place to be? Jeff, why don't you start?
Well, first I'll start with a dichotomy. If you look at RS-JAPO's primary original equipment manufacturers, there's basically 4 of them, and none of those 4 are in Michigan, and even their manufacturing centers aren't in Michigan. And in fact, one of those is in Europe. To go back to the question, why Michigan? First, with the military hub for ground vehicles at the Tank Automotive Command, both with the acquisition side, the logistics side, and the R&D community, and then all the leveraging of the automotive industry here and the tier suppliers. So why are we here? Our mission was moved up into Michigan by the Congress in the base realignment closure of 2005, and the organization I work in rooted here at the Detroit Arsenal in 2008. Since then, we began to make those relationships with industry and bring them in to provide a better piece of gear to the warfighter. So if I go into why, or what the opportunities are for the community here and what we need to do better at, there's a couple things. Number one is reliability and endurance. So the type of reliability that we take for granted, we don't tolerate substandard quality in our cars. Not to say the gear we have to our warfighters are not substandard, but the reliability, going from tens of hours to hundreds or thousands of hours between service is needed. The lessons learned that we've implemented in the auto community, we need to put into our military gear, particularly ground robotic systems. So that's one. Leveraging all the sensor work that's being done in the automotive community. Not building unique or purpose-built sensors just for military robotics. Let's leverage what's out there, either from the makers or from the auto industry, and that ties into really the biggest thing that we could leverage, and that's affordability for us on the military side. I won't say we've had a blank check over the past several years, but with the conflicts and the global war on terror funding associated with supporting the warfighter, that is starting to subside. So now we're looking at operating again in a resource-constrained environment. So I'll leave with this. I can get a luxury car for $50K. Okay, I'm paying 2 to 3 times that for one of those small robots that I showed, or more. Why can't I get a small robot that's reliable, endurance, has the agility that the warfighter needs for thousands of dollars as opposed to hundreds of thousands of dollars? So how do we get the cost benefits that the community has and bring those into our manufacturing and realize that in the reliability and quality and the mission application for our systems?
Okay, great, thank you. Corey, why here? Why Robot Town here?
So Jeff stated a lot of the same points that I wanted to make. We are a center of excellence here. I was involved with the Michigan Automotive Robotics Cluster when it first kind of the idea was formed by the Small Business Administration. Karen Mills came to town and said, I think you guys are an automotive robotics cluster. You should form this way and start to come together, build the team, collaborate, and we'll support you. We still haven't come together yet. And there's a big challenge here. We've got, obviously our big three here. Sorry, but I don't think they really like to collaborate that much. There's too much competition.
Really?
We have the Army here. Army
Jeff,
military.
there's no time for rebuttal, sorry.
And that's okay. I mean, that's business, right? We're capitalists. So DoD doesn't necessarily know how to work that well with commercial entities. The cool stuff that Jim was showing up there, that was built usually, that's built by smart people like you. So, but it's not easy to work with the military. So even though this is the center of gravity for automotive and automotive technologies, it's not an easy place to get people to work together. So that's one of our missions also in this collaboration. We have the Department of Transportation has this Intelligent Transportation System pilot going on around Novi, Farmington Hills. Most people don't know about it. It's been there for a few years now. Tens of millions of dollars into this pilot program. Still doesn't really know what the business case is yet. So one of my missions and passions is to try to get us to work together, get as many federal agencies that make sense, this is relevant technology, like Department of Transportation, Energy, DoD, Department of Homeland Security, all the folks that we've been talking with, to get us, the R&D centers, to start to work together on collaborative projects that for mutual benefit. And then obviously we bring in our commercial sector and our OEMs and non-traditionals. So that's why here, but it's not easy. We have to definitely work together.
Okay. No, I'm sorry. You get no rebuttal.
I need to go next.
Go ahead.
I would agree that there's a fair bit of competitiveness, but there's actually one organization that exists which is kind of a role model of collaboration. It's the Crash Avoidance Metrics Partnership, which is in Farmington, and it's anchored by NHTSA. And they've really done some amazing things in terms of developing standards and cooperation in terms of TSRC and vehicle-to-vehicle communications and vehicle-to-infrastructure communications. We've got smart intersections. Ford's built our own smart intersection. And I think really that organization could be put forward as a role model for industry collaboration in the future. And I think there's a high interest, and you can engage with suppliers as well, and it's been working well. We have vehicle fleets that actually are interoperable, and they work and cooperate and communicate, and it's actually pretty spectacular.
Cool.
Cool, thank you. That was a good rebuttal. Yeah. All right, Bob Kawasaki, why Michigan?
Well, let me give you the bad news first. No, the good news first. The good news is that the industrial robot was invented in America. The bad news is none of them are being manufactured anymore in the industrial space in the U.S. It's either a Japanese company like Kawasaki or it's a European company. However, why are we here is that A word again is automotive. We are required to have our service center or what have you within, say, an hour of the plant. So obviously we have all located here because this is headquarters. Not only is this headquarters for the Ford, the GMs, the American manufacturers, but we have Toyota, Hyundai, Volkswagen, a few others that are here, so we've all stayed here. We will stay here also because of the quality of the engineering and the technology that Corey spoke to. It's an outstanding place, and for those of you students in the room, we're having a terrible time finding good people right now. So there's your hint for the day from me.
So resumes to
well, maybe not. Yeah, I'll get them to the right person. And by the way, the RIA website has a job board also, just to put that out there, and that's a common thread in all of us today. We just cannot find good people. From somebody standing on the plant floor, starting the machine, to designing the things. We're having a terrible time with it.
Wow.
So
any questions from the floor before I keep going?
I'd like to hear from David on that.
yeah, let's hear from this guy. Yeah,
Why Michigan? First of all, I think Michigan has some of the finest hospitals, southeast Michigan, and now the western part of the state is developing some wonderful medical communities like Spectrum and activities that are going on in Grand Rapids, along with the Van Andel Institute. We have a wealth of talent, and we actually think we're pretty nimble at Beaumont. You think of these big hospitals as not being nimble. We can cut through red tape pretty quickly and make things happen. I think sometimes you end up surprising your leaders by, they say, you built a biobank? Well, when did you do that? How did you do that? Say, oh, inspiration from you. Thank you. So, but you know, really, we have wonderfully supportive people in the highest levels who let us do this. We also have magnificent universities. I mean, the University of Michigan is arguably one of the best universities in the entire world, and it shouldn't go to their heads because yeah, they sometimes tell us that a little bit. But when it comes to biomedical, when it comes to nanotechnology, when it comes to some of the engineering and technological sectors, it is a true national treasure here. And we have some pockets of really outstanding technology at Oakland University, Lawrence Tech, you know, Michigan State, Wayne State, and we have a lot of collaborative programs. We are not afraid to work with other universities and bringing the hospital, some of the biotech groups, and the universities together in a seamless fashion. So even though we're not automotively driven, I think there's a wealth of talent in the area from engineering and technology because of the attraction of the auto industry that brings these people into our sphere. And we encourage people to be creative and be inventive, not just to run mind-numbing phase 4 clinical trials so that Lilly can make more money than one of the other drug companies or so on. Sorry, we're not interested. What we are interested in is innovation, and that's where we're heading.
Great, thank you. All right, so we have a question right here. Go ahead.
I'm Rakesh. I come from a nanotechnology sensor company. The company was co-founded at the University of Michigan Labs. The question for me, I have a couple of questions. One to Dr. Felten and one to the general panel. Dr. Felten, what you mentioned about micro-robots and nanorobots was very impressive. But realistically, where do you see the FDA coming into the picture and saying, you know what, this is ethically violates the micro-robots, it doesn't make sense, it's big to have them. And where do you see FDA's role? Because FDA is one of the biggest limiting factors for any medical technology. Yeah. There's a stumbling block. And the other question for the panel was, because I think the future of robotics truly lies in sensor technology. Because we make sensors that are as small as a human hair. One sensor is about, and to make them more cheaper and more affordable, like Jeff mentioned, they have to be mass producible. So where do you see the R&D, the true dollars going into? Because most of the money is going to China or Asia, but very little money is being invested here in the United States with true technology companies.
Mm-hmm.
Okay, so we'll go David first about FDA, and then we'll go to the panel.
Yeah, well, it's necessary to work with the FDA on these things. If you just approach them after the fact, you get into a tangle of red tape. But we have actually found the FDA quite interested and quite willing to entertain some novel ideas. What you do have to do is show proof of concept in an experimental setting first. So we would have to develop this first as a product that would benefit, for example, veterinary animals, which is certainly a worthy goal. If we don't watch out for our veterinary animal community, our food source is going to be in jeopardy. So I think developing this first in experimental models to actually treat, for example, treating cancers. There are many animal models that get cancer, and even those who don't appreciate research in experimental animal models, I think would certainly be interested in anything we can do to improve the health of our large veterinary animals, horses, cattle, sheep, porcine species, dogs, cats, animals like that. So I think we have to work hand in hand with the FDA and get them involved in this and get them to understand what we're doing. I don't think this is dangerous technology. Having an antibody tagged nanosphere that can go in and identify a molecule and release a compound to kill the cancer is no more dangerous than radiation therapy or no more dangerous than expanding a stent into a coronary artery, which I think is really a more challenging and provoking process that can have side effects.
Okay, so panel, sensors. R&D for advanced manufacturing or mass producing, is there any such dollars for such a thing? Where do you see that going? Jeff, you look like you got a comment, so Jeff R, why don't you start?
Yeah, I don't, at the risk of being a buzzkill, I don't know that we really know what the winning sensing technology is going to be. Whether it be radar, vision, LiDAR, fusion of the above, you know, a multispectral version of it. Once we get a better appreciation of what is needed in the real world, in real world situations, you move from the laboratory into the proving grounds, into the real world, start getting some real good data, and you exercise it at night when it's raining, when it's foggy, you know, in all kinds of situations. If you come up with a sensor that can detect ice 300 yards ahead on the road, great, you've got an idea, but it's going to have to work with all those other sensing modes that have to be there. So in the meantime, we come up with kind of specialized, special purpose, limited purpose sensing technology, and the more that we can kind of expand those for, you know, put those on the high volume part, not just the low volume Lincoln, but on the high volume Ford Focus, so that everybody gets benefit from that. Then we'll gradually learn. I don't think there'll be a day where all of a sudden we flip the switch overnight, we say, okay, this is the winning sensor, and we're going to start mass producing. Okay, I think we're going to gradually creep up on it. But I think there's still a lot to be learned, and I don't know that it's 1 year, 5 years, 10 years, 20 years out before we really understand what that's going to be.
Okay. Anybody else want to?
Well, I'll say on the military side, for military robotics, our holy grail is something approaching the human eyeball. So that's where we want to get. We want to be able to have a sensor that has the range and resolution that we have. The whole processing of what we do with that and the reasoning behind it is a software piece. We're focusing on the hardware. There is defense dollars going into the research to push range and resolution and all-weather operability for sensors. Some of the technologies that Jeff talked about are where we're looking into, if it's different wavelengths of radar or LiDAR, stereo vision, you know, ultrasonics, but fusion of those sensors is right now kind of what we're thinking. Mass production, we don't have any mass production activities. There's a defense initiative called Manufacturing Technology Objectives that are, what they look at is if you take a LiDAR sensor and kind of decompose it into what's the cost driver for that $75,000 Velodyne. Is it, I don't know what it is, the receptor, or, you know, whatever it is, and then focus on that. We've got programs that can say, okay, of that $75,000 sensor, this widget is 40% of the cost. If we can get that piece down to half of its value, we drive the cost of the overall sensor down. So there's a number of those objectives going on within the Department of Defense. And then in labs like CARDEC, where Jim is from, and Army Research Lab and DARPA, there are individual efforts that are focused on sensor miniaturization, ruggedization, and with the goal of reducing their overall cost.
Okay, we'll have one final question here in the back, probably, unless, Andy, you think that we have a few more minutes? Or?
Let me ask a question. Go ahead.
Oh, okay, so let's, okay, two more, go ahead.
Bob Jones, Lenawee Intermediate School District. I represent the tech school in Lenawee County. And I have a question that's really kind of, it's a little bit of a shift, but I think it's an equally important shift, is to the discussion panel as well as the folks here. We talked a lot about the hard side of robotics today, you know, the military side of it, the automotive industry, the robotics industry. My question to you as a broader is, how do we soften that edge, and how do we make that more accessible to our kids? I know Bob mentioned that they're having a hard time getting qualified applicants, and from my side, from the technology side, we hear this all the time, but we don't always see sort of that motivation that we need from kids that say, I can do this. Not that they're not capable, not that they're not motivated by, I want a good paid career. But from a broader spectrum, one, I can do this, and there is a very clear path, and there's a very clear connection to the medical community, the military community, the automotive community. Robot count sounds like a great start. So my question to you is, how do we make it more real, more present? You know, we have robotics first out here, and I think that's the first step. But how do you see us making it easier, not only for males, because this is a male-dominant room, my coworker mentioned, but also females, so that they see this as part of what they want to do in their future. So that's the question.
I've been the only engineer in the room for a long time, so I can feel it. All right, so before you guys start, let me answer first that this afternoon is dedicated completely to STEM activities. So it's all science, technology, engineering, and math related to our students, both at the high school and university level. We've got lots of university representation here today and our 5 FIRST teams, which is great. So just want to put that out there, that stay this afternoon, and we'll talk some more about that. But let's go ahead and hear about it. So let's have Bob and then Jeff.
Okay. The RAA currently has initiative, a committee that's working on educational outreach. So let me talk to you about that later. We can help you with that, at least for industrial.
Jeff?
I won't talk about FIRST. I think that'll be brought up here at STEM, but a couple weeks ago, there was a gentleman at a conference that talked about FIRST. It was a great speaker. And the one thing that stuck with me is look at our children, our kids' heroes. Who are they? You know, Tom Brady, LeBron James. You know, the athletes are their heroes. They're who they emulate. Putting robotics into a competitive environment, and you look at who excels in there, you know, I think if we can, as a ground floor movement, get the idols for our children to be those type of individuals, that groundswell could happen and embrace, you know, a little more than, you know, now kind of looking at the geeks with the robots.
No, and it's sexy, it's attractive, it's encouraging, and it is the pathway for kids to say, it's real. In other words, I can be that person. And I would encourage you and the folks in the room, I know I'm kind of on a soapbox here, but I would encourage the folks in the room, you know, talk to those kids, show them I'll use a classic, iconic example. You watch television, and invariably when they talk about the smart person in the room, they have glasses on, and they have a lab coat. That's not who you folks are. You know, you're everyday people, and I think that we need to work a lot harder to help kids feel that what you guys are talking about, what you're doing, which is wonderful, and the folks in this room, that it's real, and it's the person that lives next door that's doing it. And they may be a mom as well as a dad. And they may be a football player as well as an engineer. So to help kind of soften that, that's what I said about the softer edge, is help soften that edge around. You don't have to be somebody different to be a roboticist. You don't have to be somebody different to get into this business and be successful. So.
And a quick one, Sarah.
Yeah, okay, so Corey and then David.
This is exciting. A couple things we're doing. One of the projects that we're working on, actually for the Army, this is really neat, I think, is the social media campaign to build the robotics community. And we identified all of these different targets of people that, you know, from scientists to university professors, et cetera. And our first target was teenage girls. We thought if we can get teenage girls interested in robotics through some social media campaign, then we're going to start to build a really interesting community. So that's starting to happen. It's pretty fascinating. Also, again, back at Robot Town, there's an entertainment element to Robot Town. Is when we build this thing, it's going to be a place to hang out. There's going to, if we have retail in there, they have to agree to have some kind of robotics in their retail. Say if it's a Pizza Hut, they have to serve through robotics, or they have to pound the dough with a robot, or something like that. So they can see them in real-world environments. And then the last thing is taking a lesson from Asia, you know, Japan, China, Singapore, Korea. They're doing a wonderful job, kind of what you were saying, Jeff, of creating these really neat competitive robots, soccer players and dance teams and things like that. So those are some of the initiatives that we're trying to soften it up, like you said.
Okay, and then David, last comment on this topic.
Yeah. We try to make available opportunities for high school students. You have to be careful not to get too young, but for the students to come in and really appreciate the incredibly sophisticated technology that exists and have them watch and participate and realize that they can actually become part of the process. And they almost become proud of being a nerd. You know, just like everyone at MIT is proud of being a nerd. They worked hard for it. And we have actually been able to develop some of our joint Oakland University William Beaumont Hospital projects to engage young students, high school students. And at a recent symposium, one of the presenters was a high school student who had gone to a national meeting and presented component of the research there. And those are the students who, when you hook them early and get them interested, they will be coming down the job market and will be available to participate.
Sure.
Okay, so we'll have our last question from Rick.
Okay, I want to start with a little bit of a rebuttal to Jeff's rebuttal of Corey's earlier statement, and that is, you know, it was the comment about NHTSA being a possibility for collaboration. Well, at NCMS, we've been in conversations with people at Department of Transportation and NHTSA, and they said one of the big problems you have in Michigan is nobody wants to collaborate, and they said, and you're all real bad at it. And you won't share, and you won't talk to each other, and so NHTSA comes to NCMS to say, look, you're the experts in collaboration. How are you going to make that work? You know, let us go to work on that. So with that said, you guys, you five guys are all doing great work. And what's it going to take to get? What would it take to get all 5 of you collaborating on the same thing? And let me give you something. A couple of weeks ago, we were at a number of us were at a conference in Orlando where we heard about the numbers of companies around the world that are heading off to Japan, robotics companies, to help with the crisis over there from all over the world. And it seems to me that something like that, the 5 of you on a collaborative team, could make a huge difference in, and there are millions, if not billions of dollars available right now, public and private, to get companies pulled together to go over there and help solve some of those problems. So I guess my question is, what's it going to take to drive collaboration from your perspectives?
Who wants to eat that first?
Leadership and money. You know, and,
Hold up your sign.
oh yeah, Mark's got money.
Oh, he's got his sign up. He put a $1 sign on his.
Well, there's money on the table.
Yeah. So
Yeah.
you know, Japan is really interesting. They're way ahead of us in
Yes.
their robotics technology, and part of the reason, you know, this is opinion, is because their government is exercising leadership. And again, educating through Dan is. They have national leadership all coming together to do this initiative. We just kind of talk about it. We say nice things. We want to collaborate, but we don't have a president's agenda on robotics yet. You know, OSTP I know is working on it, but so that's what I say: leadership and money.
And also, there's competition between some of the universities and some of the industries competing for dollars that are made available at the federal level. And in fact, there's a group of hospitals that have now pulled together called the Dartmouth Collaborative. And they're taking a role of leadership, saying, okay, we've got to find what are the best practices for how you handle cholecystectomy, how you handle stent placement. And they're just taking over in the private sector with the leadership. Once you get an inspired individual who is expressing that leadership, I think you can rapidly pull together the directors of research and some of the leaders in the individual industries, but you need somebody who's going to take ownership of it. You need somebody who's going to say, we're going to go after this. It's sort of the way, you know, we decided to build a biobank in a core molecular lab. That happened because somebody took the bull by the horns and decided, we're going to do this, and we're going to pull everybody together in the hospital, and bam, 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 it started to happen so quickly that everybody wanted to be part of it. That's the level of leadership.
I think it's clearly the potential for performance improvements, that potential's there, collaborating across the industries. To break down the barriers, you know, one thing I think that would help is a kind of like a tangible ROI. So what would be in it for the body? Are there's got to be efficiencies that could be gained that in the capitalistic economy, that the bottom line is, you know, the dollar. I already talked about constrained resources. So what are the efficiencies that could be gained in affordability, program execution, even in and it sounds antithetical to collaborating across these monolithic industries, but cutting down processes. You know, just working within the military, the processes and the time it takes to establish an acquisition program and field something, it's way too long. So what are those process efficiencies that we can gain by, you know, maybe there's, you know, the auto industry has figured some piece of it out, and the military has another piece about fielding, and logistics piece is somewhere else. You know, looking at across all those industries, I would put that puzzle together to, you know, make a, or what, it's going to take leadership, as Corey said, but to make the business case, you know, why does it make that sense to do that?
Jeff or Bob, either one of you want to throw in a thought? Or
Just a quick response. I think the area of robotics for the autos is it's in its infancy. It's really just emerging, and there's so many collaborative opportunities. It's a matter of prioritizing. And we have to look first for where are there aligned objectives. And for me, the DARPA Grand Challenge, the first one, was kind of like an eye-opener. It's like, wow, there's so many exciting ventures out there that want to play, and never worked with, you know, and there's so many little companies here in the area, Cybernet and Quantum Signal, and it's really neat to meet these folks and get that energy going, but it's a matter of priorities, and I think there have been some good collaborative outcomes, but you're right, we still kind of think in the back of our mind, it's like, well, this is still a business, and and as long as you know where that line is, pre-competitive, competitive, and you agree to play it fairly enough all the way up front, it can work well. We just keep trying.
Okay. Well, thank you very much. I really appreciate all your guys' input, but what I'd like to encourage you to do is really take advantage of the next hour or so to network with these guys, ask your questions offline if you have that, really bring out some of this discussion, because I know we probably didn't have as much time as we would have liked to have had this. And to the panel members, thank you so much for coming and sharing your thoughts with us today. I'd like to close with just a few themes that came out. The first theme is that Michigan has a lot of really great assets, a density of technology, engineering, research, university community and research, capabilities in automotive and manufacturing that we can really take advantage of to be effective and successful in this industry. But second, probably there's a lot of opportunity for cross-pollination of some silos, and how can we be more collaborative in our efforts to make Michigan as a whole successful with respect to utilizing some of that talent and assets more effectively. And then finally, safety is an issue, and that might be one of the next tough nuts for us to crack in terms of being able to utilize robotics in all of these different industries. So I'll leave you with that, and I'll tell you, this guy from Ford, Jeff Rupp, he said, do cool things until you die. So that's what I'd like to encourage you to do today. So it is also my great pleasure to introduce lunch. We will leave from now until 12:45. There are two areas. You can get lunch back here. You can also get lunch out in the lobby. Please take opportunity, like I said, to network, talk to these guys, talk to some of our panel members from this afternoon, but also Lawrence Tech University and Oakland University and Commerce Connect all have some tables and displays in here. We've got University of Michigan, Cybernet, and then also some of our FIRST teams are displaying out. Please take an opportunity to check out those tables. Talk to those guys. We've got some high school students, graduate students, researchers, university folks here. Take advantage of that and talk to them. So please enjoy your lunch and mingle around. And 12:45, we will be back in here ready to go for the afternoon. Thanks again.
Yeah.